Hey Gideon, how's it going?
Good, man. How's it going? Great to be here.
All right. So why don't you tell us a little bit about yourself? Tell us a little bit about Comet and what you're doing there.
Yeah, absolutely.
Oh,
So my background, I actually started my career as a software engineer, full stack, fortunately a long time ago. And then I shifted to working on machine learning about 11, 12 years ago. Funny enough, I actually worked on language models, but that was before they were large, efficient, or cool. Language models started really as a subcomponent of speech recognition systems, but this is pre-transformer days. And then I was in grad school, and after that, I went to Google. I also worked on language modeling there, specifically for hate speech detection on YouTube comments. And that was kind of like my first experience of what it is to build machine learning and AI products at at massive scale. And there were lots of learnings there, especially someone coming from a software engineering background. And after my time at Google, we founded Comet. Essentially, Comet manages the entire end-to-end workflow of building AI and GenAI apps. So on the MLOps side, all the way from dataset versioning, experiment tracking, model registries, and model monitoring. And then more recently, last year and a half, lots of our customers are, of course, asking us to support them on their GenAI LLM initiatives. So I'm sure we'll talk about it more, but we launched Opik, which is an open source end-to-end LLM evaluation framework. So that's our focus on the product side. To tell you a little bit more about the company, we have about 100,000 devs on our community product. And then we power the best Gen AI teams in the world. So whether it's Netflix, Uber, Etsy, Shopify, Stability AI, and really many, many, many more.
very cool. Yeah, I saw the launch for Opik, and I thought it was really exciting, especially that now you guys are also getting into the open source space. And if you guys have been following me, to the viewers, you know that I've been talking a lot about open source stuff. I think one of the first things that would be good to get into is, why does LLM evaluation matter? Why is it so important for people?
Yeah, absolutely. I think if you think about the maturity of the space, it's quite interesting to see how it follows this like natural Gartner curve, right? When you look at building Gen AI apps, what's really cool is setting up a POC or putting something that kind of works is actually quite easy, right? Like if you're building like a RAG application using like Llama Index or LangChain, you can get something up and running in like a day or two, right? Which is amazing, right? And a testament of like the open source community.
Yeah.
But getting it to a point from that POC phase to actually something that adds value in production to customers, to users, whether that's internal employees or external users, is actually really hard, really, really hard. And there's multiple reasons for that. And the answers for most of these problems is proper LLM evaluation methodology and tooling. One of the reasons is there's like tons of moving pieces in these systems, right? So you have software, which you always have, and like we're relatively good at kind of building software as an industry. But then in these like RAG systems, for example, you have the LLM provider, which could change. You have the prompt, which usually changes quite often. You have the context, you have the vector database chunking strategies. There's so many moving pieces, and you really have to tune each one of them quite considerably to get to that point where it works well. So that's kind of like, okay, so like you got this part, let's say you've done all this tuning, and then you want to launch it to production. One of the most, I think, in my opinion, like important aspects of software engineering is testing. In software engineering, unit testing, integration testing is what allow us as engineering teams to actually ship something and know that we didn't break 10 other pieces, right? I started writing software as an organization that didn't do a lot of testing, and it's quite painful. I mean, it was like earlier days, but we were kind of pushing files over FTP to production servers. But using the same methodologies for these Gen AI apps like doesn't always work, right? So if you think about unit tests, for example, right? Like, how do you unit test an output from an LLM, right? So you can do string matching, sure, but like, what if something changed in your system and the answer is semantically the same, which means you should be good with that answer, but the string is actually not identical. So these like simple assertions break, and you need an extension for that to this new concept of Gen AI. And then the last piece, which is I would say like relatively similar to like the traditional ML world is once you put it in production, you're like, okay, it's running in production. I want to know what's happening. And I want to use what I'm seeing in production to like iterate and go back and improve. I mean, once you put a Gen AI or a machine learning model for that matter in production, like your work is not done. Like I've seen it at Google, like in most cases, you just got started. So
Yeah.
having proper evaluation methodologies and tooling is absolutely critical to nail those things.
Yeah, I totally agree. This is actually like a lot of what you say is very reminiscent of what I used to work on when I was working on the AutoML infrastructure at Amazon. One of the things we did was like, okay, we got to track like how is this model performing, and then how do we fix the model. So you recently launched, Opik, which is your open source LLM eval tool. Tell us a little bit about what goes into that. Like, what do you think are the most important pieces of this open source tool, and why did you decide to launch this open source tool?
Yeah, so I'll answer the second question first, right? So, Comet have been supporting some of the best AI and machine learning teams in the industry for almost 7 years now, right? And historically, those were teams that were training their own models, whether it's foundational models or models for self-driving cars, credit scoring, right? There's like thousands of use cases. About a year and a half ago, with kind of like the launch of ChatGPT, we started getting questions from our customers, right? We were started seeing them moving some of their use cases, historically mostly NLP use cases, and instead of training or fine tuning their own model, they were trying to use an LLM provider and prompt engineer it. And then they started hitting those issues that now I think a lot of people are talking about. But we got that exposure very, very early on, and they came to us and said, "Hey, like you're really good at machine learning experimentation. We love your product, but like we need help with this use case, and we need help to track these LLM calls and things that are not necessarily, what weren't part of the original scope." So we started, taking that feedback and improving the product, and it added additional features. But then very quickly, we realized, hey, like there's a lot of scope here. And like we're big believers in open source. This is not our first open source project, but we realized, hey, it makes sense to actually take this functionality and package it up as a standalone open source project. It's still available on the platform. And decided to do that. We launched it on GitHub. It's truly open source. The thing that annoys me the most is, kind of like fake open source where the license doesn't allow you to use it, or like the code is there, but you can't actually run it, or you can run it, but the unit tests are not there. So this is truly open source, front end, back end, SDKs, the whole thing. Launched it on GitHub, and it's one of the, if not the fastest growing project in the space. We already got like amazing companies like Meta, Google, Amazon adopting it both for their own Gen AI use case and also embedding it in the platform. But when we think about like what Opik solves, like we actually worked backwards, right? We started like, what are the things that customers need? What are the things that developers need to actually build successfully Gen AI applications? And we solve for that. So in my opinion, that like there's like four key buckets, right? So the main one, or the starting point, is just observability, right?
Right.
These systems have multiple moving pieces. We have chains, you have agentic graphs. Like, how do you know what the hell's happening, right? It's really hard. It's really hard. Like, imagine all these tool calls, and even if you're building like a simple RAG app, it's still really hard. So the first thing we want to be able to do is being able to inspect what's coming in and what's coming out of every step of this application. So that's the kind of the core first bucket, having visibility. Now after you have that, that's where comes the human feedback component. And in my opinion, it might not be cool, it might not be techy, but that's the piece that adds the most value, right? So just by examining a dozen, 2 dozen samples, you will identify a bunch of things that are inherently broken. And in some cases, not always, unfortunately, but some cases easy to fix. So there's a whole suite around annotating. How do you annotate things? How do you build these categories? The other side of it is like the person that developing these apps are not always the expert on what's right and what's wrong, right? So we see customers have like a domain subject expert doing these annotations. They don't need to be technical. They just need to look at the responses. Now, once you get some of these annotations, it's kind of, you worked on ML, right? Like it brings us back to the regular ML world where we have like an annotated data set, right? Like a golden data set, which supervised models, like, that's like the very basic stepping stone. But this concept actually translates really well for this as well, because once you have this golden data set, let's say in the RAG app, there'll be an example of questions and answers where the answer is correct. You can actually start testing against it in a more automated fashion, which is really cool, right? You're not vibe checking, you're not just changing the prompt and thinking this is better. You can actually have true experimentation on how well you're doing. And then there's typically like two core metrics or types of metrics that work in these use cases. The first one is like, heuristic metrics. So let's say we have a question in our data set, our golden data set, of which city is named the Big Apple, right? So maybe your answer says, your data set says NYC, which is, happened to be the right answer. But when you ask your LLM, the answer was New York, not NYC.
Yeah.
So your string assertion breaks, right? But in reality, semantically, it's the same answer. So that's where you can use like distance metrics, like bird distance, for example, set a threshold and say, okay, if it's above 0.9, I'm good with the answer. And that allows you to kind of iterate on the prompt and knowing that you didn't break something fundamentally. The second type of metrics are what's called LLM as a judge metrics. In that case, it is a fancy name. The scientific community, those archive papers always have a fancy name, but really what it means is you take the entire package of the input, the context, the output, and you ship it to another LLM and you ask it, is this good, depending on the metric that you're looking. So this could be used for hallucination detection, answer relevancy, and so on. LLM as a judge metrics are not perfect because you're introducing a non-deterministic factor again.
Yeah.
Yet they do allow you to move much, much, much faster. And that's when we've seen teams implement this methodology, and it's tool independent, right? That's where you start seeing that flywheel. You get more data, you annotate it, you test against this, and then you actually get better results much, much faster. It's pretty cool to see. So those are like the core things. Opik specifically is focused on solving these problems. Among other things, there's a lot of smaller pain points and paper cuts that we help with. But that's, I would say, kind of like the core functionality that we're focused on. One thing I didn't mention is like the production observability, right? Like you want to be able to do that in production, in scale, in a smart way. So Opik, because again of our customer base and their scale, we had to build it from scratch for like pretty crazy QPS numbers. So it's really cool to see. I think there's some kind of independent benchmarks that mention Opik the most scalable. I wish we didn't have to build it. It's hard, but we did, and it's working really well.
Okay, that is very cool. Do you, off the top of your head, do you know how many QPS you kind of had to deal with?
There's it's super dependent on a bunch of factors, and is it for just tracing? Is it for the evaluations? I don't have the exact numbers at the top of my head, but I think we have a write-up on our GitHub repo that actually calls out exactly. We're using ClickHouse as the underlying database, which doesn't solve all your problems. There was a lot of fine-tuning and work that needed to go into that, but I think it's on our GitHub repo. If not, I'll make sure it's added later today.
Cool. And send me the link. I'll share it out with the audience. So we've got a few minutes here. Audience, if you have questions, now is the time to start dropping them in there. I think now would also be a good time for us to kind of just show you what Opik actually looks like. I know this is a pretty new product, recently launched, very complex. From what you've said so far, there's a lot of moving pieces. I think it'd be great to show a demo.
Yeah, absolutely. Do you want to jump in, or should we wait for a couple of questions?
Oh, let's just jump into the demo. If people have questions, I'll throw them at you during the demo.
Cool. All right, let's do it. So let me present. Okay, just make sure. Can you see my screen?
Yes. Can you zoom in a little bit?
Yeah, I'm not going to focus on this. I just want to say if anyone wants to see it, it's on GitHub, comet-ml/Opik. Everything's available there. But yeah, I'll switch to a demo. So I have. Let me know if you can see it. Is this okay? Can you see this now?
Yes. I still think it might be a little bit better, a little zoomed in.
Zoomed in. Is this better?
Yes, this is way better. Okay.
Cool. All right. It's like huge on my screen, so hopefully it still looks good. Cool. So I have like a super simple Colab notebook here. We're building a simple RAG app, right? I'll go through the code super quickly. We're not gonna like go into super detailed, and then I'll show what it looks like on the product side. So here we're just installing Opik. It's a pip install and OpenAI. Again, Opik, I'm using Comet.com, just like a hosted version because it's easier, but you can install it on your laptop in like 5 minutes. It's also available natively in SageMaker. This is from last week's reInvent. If you're a SageMaker customer, you can get the whole thing out of the box. Yeah, I was like on the main keynote, pretty cool stuff. But yeah, I'm installing the Python SDK. I'm configuring my project name, API keys, some more dependency installation, and then essentially I'm first setting up like the vector database, right? So in this case, we're building a RAG chatbot and answering questions about how to use Comet. Again, it's a very kind of toy, simple example, but we're pulling a page from our docs, and then I'm chunking it, adding it to creating embeddings and adding it to ChromaDB vector database. This code, everything you see here is just kind of standard LangChain. Now, once we have the data inside the database, I'm defining just a simple RAG app, right? It has 3 functions. I'm just defining, hey, this is my LLM provider. This is my vector database. I'm defining a function to get the embeddings, getting the samples out of the vector database, so the invoke, and then just a simple get answer where we take the context and we feed it to an LLM. In this case, it's OpenAI, but we support essentially all of them. And that's it. So that's how long it takes to set up a simple RAG app, right? Like literally, that's how long it takes. And then we're just testing it. So we're asking a super simple question. Hey, I have a system prompt where it says you're a Comet expert. You love explaining Comet concepts. And then the user would ask, how can I log a system metric into Comet? Super simple. And I'm printing the response. So far, everything we've seen is code. Let's switch to actually Opik and see what it looks like. So again, I'm demoing this on Comet.com. This will look exactly the same in the open source version. It's real open source. There's no missing functionality. We're not hiding anything. The whole thing is available locally. And I can see I have a bunch of LLM calls here because I've been running this for a while, but let's look specifically at this one, which is that sample question I asked. So if I click on this, on the left side, I can actually see these different functions. The zooming in messes it up a little bit, but I can see all these functions that I defined in my Comet bot class. And I can start by looking at it at a high level. So the question was, how can I log a system metric to Comet? And then I have the system prompt here, and I can see the response. You can log a system by calling log system info, which happens to be the right answer. But I can actually dig in, right? I can see when I look at this, this is the retrieval function from the vector database. I can actually see that when we asked the vector database and it did like the cosine similarity between the 2 vectors, it pulled the right thing out of the docs page, right? Now, in this case, it worked, so cool. But in cases where it doesn't work, knowing what came back from the vector database is extremely useful because garbage in, garbage out. But yeah, and then we got a lot more here on, we can measure token cost, latency. There's a lot more functionality. But let's go back to the notebook, and you keep me honest on timing. I'll have
about 2 minutes.
2 minutes. All right. So I'll go through it really quick. What we're doing here is what we talked about. We're creating a test data set with the right questions and answers. And then we're actually running an automated evaluation against it, where we're iterating on different system prompts against the same data set. So this is where we get to this automatic flywheel. And specifically, we're looking at 2 different metrics, hallucination and answer relevance, both in this case, LLM as a judge. So switching back to Opik, I can see here the data set that you saw me create in the Colab notebook. So everything is saved here. Try to zoom in a little bit. But then we have the experimentation factor, right? So here's where it gets really interesting. So we ran 3 different system prompts. So I have 3 experiments here, and we tested them for answer relevance and hallucination. And I can see that clearly, like this one has the lowest answer relevance, so higher is better. And it had some hallucinations as well, versus this one that had the best answer relevance, but the lowest hallucination score. But what's really cool, I can actually select those things and hit compare. And I can actually look at the answers, right? So like, where did I get it wrong? It's just numbers are not necessarily as useful. But I can see, for example, where let's look at one that had a low score, right? So in this case, this experiment had 0.7 versus 0.95. And I can actually look at the responses, and I can dig in, because it's not just enough looking at the response. I can see again back to what happened in retrieval. So I'm going super fast. There's a lot more functionality here, but I'll pause here because I know we're probably almost on time.
You're actually exactly on time. If you could send us a YouTube tutorial or something like that, I will drop that in the link and I'll send that out to the audience and we can all see that later. Now we are out of time. Thank you very much, Gideon.
Thanks, Eugene. Great to be here, and good luck with the rest of the speakers. Looking forward to it.
See you later.
Cheers.